Hello, everyone. Welcome to today's webinar on wind farm projects. We are going to be talking about a couple different workflows that you can use for road optimization for those networks. If you don't know me, my name is Erin. I'm the Business Development Manager at Softtree, and I also get to be one of our resident webinar hosts. And I have the pleasure of having our Training Manager, Matthew Dickey, with me here today to tackle the lion's share of the webinar presentation. So as I mentioned, today we're going to be talking about two different workflows. And which workflow you use and why you use it really can depend on what stage of your project or your wind farm design process that you're in. So we're going to be looking at first a really high-level initial preliminary road network plan. We've got some turbine points. We're going to figure out how to best connect them and where to best put our roads to get some initial construction costs. In the second half of the webinar, we're going to be doing a much deeper look into what that road network could look like, including in it the pad geometry for the turbines and the laydown areas, and optimizing those earthworks with a little bit more detail as well. So a couple quick reminders. First off, please do ask us questions. We love answering them. We've got a couple of moments in the webinar where we're probably going to have some calculation times. If you have a question, ask it. We can tackle it there. And you do remain anonymous, so it's just a typed question. And we won't tell anyone who you are, so there's no such thing as a bad one. And then my second kind of reminder, I know we mentioned wind farm, and I think I just used that term about 6 times in the first minute of this presentation, but these workflows are really not exclusive to wind farms. They can actually apply to lots of other road networks and resource road projects. So the turbine locations that we're going to refer to inside of the actual presentation can really refer to any start, end, or destination points. And hopefully you can pick up some useful tips and tricks for these different types of workflows. One's really fast, one's a little bit more detailed. So the first workflow, the key steps in this sort of really high-level initial preliminary road design workflow, we're going to start by building a surface. And terrain works with a whole variety of different survey data types. In today's example, we're going to be working with LiDAR tiles in LAS format, but we work with GeoTIFF, we work with DEM data, as well as other sort of more conventional survey types. We're going to be importing our turbine locations, and then we're going to quickly explore the potential road locations between those turbines. From there, in this first workflow, we're going to leverage a couple of the sort of more quick optimization tools inside the location module to convert those Path Explorer paths into simple road designs, get some initial quantities. And that's really, kind of encompasses the key steps in the first of the two workflows. So with that, I am going to pass the screen over to Matt.
So we're going to start out right from square one. And with that, we're going to start in terrain. So we're going to end in location for our proper linear infrastructure design, but we start out in terrain to bring in our survey data. In this case, we're going to use some LAS data, and of course, LAS in this case we support a bunch of different file types. So LAS, LAZ, DEM for the common LiDAR formats, but then conventional survey data and of course other formats from other software. So I brought that LiDAR data in. Next, I'm going to just quickly turn it into a tin. And in this case, I'm going to have a lot going on. I'm going to use the 3D view for really getting a visualization of my topography, and I've turned contours off. So by no means necessary, but personal preference. So we have a surface. And I'm going to do a couple optional steps here. And just for some added context, I'm going to bring in an ortho image for my area. So I'm connected to a web map tile service. In this case, we're using Google's web map tile service. And we'll just download some imagery here to make it a little easier to see what's going on. and shouldn't take long. Now with this, of course, we're seeing it on the web map tile service here, but we are downloading that. So if we were to go to the camp or somewhere where it wasn't easy to download that, well, we'd still have access to it. And so download's done, just stitching those images together. And we'll choose where we save this. Let's save it right there. There we are. And next I'm going to, well, in this case, I want to know where the streams likely are. So I'm going to use our streams and ponds tool. And of course, with all of this, I'm going to want to know where the turbines are that we're actually dealing with. So I'll bring that in as a shape file. We'll make it a little easier to see that shape file. And there we are. So we want to go to these 4 turbine locations in our little example that we're running with. Now, we're going to switch out from kind of getting things set up, and we're going to start designing. And the first tool that we're going to use here is our Path Explorer tool. I'm going to say, well, I want to go from here to here. So I'm just drawing a feature. And then I'm going to, well, set up my parameters. So we're going to go into optimization, Path Explorer, and we are going to put in our parameters. So I want a minimum horizontal radius of 50. It's not super flat, but flat enough. I'm not going to go with anything crazy for my grades, so I'm going to go plus or minus 8%. And I'm going to, well, leave my cut and fill costs are appropriate in this case. So as the software searches for the cheapest way to get from here to there while maintaining our design parameters, it's going to consider our cut costs, fill costs, and surfacing costs. Now with this, I also wanted to consider something else. So I'm going to click construction zones. I'm going to click new, and I'm going to add a construction zone for all of my streams. So of course, costs money to move dirt, but it also costs money to install crossings. And we could split that up in varying levels of detail. I'm going to go the easy way here and just apply a flat rate for all those minor crossings of $2,000. Now we could hit OK, and we'd probably get something appropriate, but I'm going to do one more thing here, and I'm going to say, well, I want this to start out. So the possible solutions that it gives, I want it to start out pointed in that direction. And as it comes into this turbine location, I want it to come from that direction. I'm going to uncheck that. It doesn't matter for this one, but it will later, and I don't want to forget to do it later. So we'll hit OK. And so it's found 5 paths. It's looking for better alternatives. And shortly, it will narrow in on, it's found the best solutions given the parameters that we've given it. And it'll say unlikely to improve further. And once it says that, we can hit cancel, and we can see what we're dealing with. So for this network problem, we've got our first A to B, and the remainders we're going to treat much the same way. We're just going to kind of rinse and repeat. So let's do this here. Now here, I want it to start out being pointed in that direction again, but at this other, and I don't really care what direction it comes into that turbine location. So I'll hit OK here. Again, found 5 paths, looking for better alternatives. Unlikely to improve. Great. And so with that, we've got something worth mentioning here. When I ran this, I was telling it to give us 5 different solutions. So it did, and our solutions are very close together. Now the 5 different solutions that it give are going to be within 10% of the lowest cost one. So here we can see, well, they're all pretty similar. Where out here, it's still within that 10% cost, but we've got a more diverse selection. And well, it's prioritizing choosing routes that are different from each other within that 10% limit. So here, well, we can't move way over here, or it's going to cost a lot more, but here we have a little bit more freedom in where we put it and staying within that cost. So I'm going to run this again. Now, this time, well, I still want it to start out being pointed in that direction. And at the end here, we want it to come from that direction. And we've got multiple solutions here. I don't really need to see multiple solutions for, well, the next couple. So I'm going to just tell it to give us 1 path. We'll hit OK. And it's still narrowing in on just being sure that that 1 path that it's found is the one we want. Unlikely to improve further. Great. And we'll do it once more. From there to there. We'll go there, and sure, let's run it that way. And this one takes a little bit longer. So, yeah, of course, it's the webinar 2 today, so it'll probably, based off this morning, it'll probably take somewhere between a minute and a half to find the cheapest route from A to B on this last one. And with that, if anyone does have questions, we'll have a little bit of an opportunity here. Otherwise, I can certainly keep talking about kind of where we're going with this while we run through. So momentarily, it should say that it's found a path. And kind of where we're going with this is, well, we'll review the options where we have those 5 different solutions to kind of pick ones that we'd like to pursue. And then we'll join these, well, the routes that make sense to keep as one road, we'll join those together and we'll take them over into location here momentarily. And unlikely to improve further, we'll hit cancel. We'll hit OK, and there we are. So, like I said, we're going to join some of these together. So obviously we're going to run with those. But at this end of things, where we have all those 5 different routes, if we wanted to, we could, of course, just make a visual assessment on what one we think is worth pursuing, or we could go based off of the metrics that we're using. So we can right-click, select feature by name. And so here we can see, well, we've got XPath 87K versus XPath 100K. Well, that number that comes after XPath is our expected cost. So cheaper is generally better. Let's turn that one off and delete these others because we don't necessarily need them. And then with this, well, we can see we're basically running the same route to get from point A to B or A to C, well, there's no need of doubling up road there. So let's just break that and get rid of the portion that we don't need. So down here, same thing, select feature by name, and I'm just going to get rid of the ones that cost more. I'm going to join these two features together. And we are going to save this. So File, Save As. Let's call this Topo No Pads. Of course, we'll do pads here later. And we're going to minimize this. We're going to jump over into location. We are going to click New File. Oh, and I don't want this morning's files. I want the ones that we were just working with. So I'm going to reference that topo file that we've just saved. We'll hit OK. I can select what features I use for my initial alignment. And just as a quick note, of course, we've ran Path Explorer. We'll use those, but if we wanted to click something in by hand, we don't need a Path Explorer feature. We could choose our location manually if we wanted as well. But this is going to give us a better solution and it's going to be faster, so we're going to run with that. All right, so I can see I've got two roads over here. I can click which one I'd like by activating it. We're going to start with the longer one. And well, I'm going to do a couple things just optionally. Again, we took the time to download that ortho, so it's nice to keep that visible just for context. I'm just adding that in as a background. I'm going to click zoom to extents for my 3D view and just quickly update the display list so we can see that. And if we wanted to, we could, well, change our template. So our template is our cross section. And in this case, I'm quite happy with this default template. But basically templates are more or less a fillable form where we can change the geometry of things and behavior of things. So some of them have logic. Yeah, if I want to just say, well, what does this look like if I have a 5 meter width on that side of the road, I can change it and it updates in real time. But we're going to run with our default. And then I'm going to get into the realm of, well, getting my alignment to behave the way I'd like. So right now that alignment is a polyline. So just a series of lines connected at vertices. And of course it would be much, much better if they were just curves and we didn't have to trace everything out. So we're going to go up to corridors. We're going to click the drop down here. We're going to click polyline to alignment. We can set our minimum radius. We can set a max offset, so a little tolerance there for how much it'll straighten things out. And we'll let this run. And we could let it run for a little while here, but that's awfully close to my tolerance that I set. So I'm going to just hit cancel. We're going to run with that best solution so far. So there we are. We can see we've got curves and tangents along our entire road. And then, well, we ran that optimization with Path Explorer, but we're going to look at it in a bit more detail here now, and we're going to get a proper vertical alignment out of this thing. So for that, the one thing I'll preface it with is we have ground types. So I've got assigned by range, subhorizons. I'm just going to run with the default ground type. assigned here. But these ground types, so my overburden is my default. I've got an excavation cost associated with it. And aside from just the excavation costs, I've also got some haul costs accounted for here too. So my overburden is going to cost $3 a cubic meter to excavate, $6 a cubic meter to turn it into an embankment. So that fill cost or embankment costs. And I've got my haul costs accounting for that longitudinal movement. And I won't get into it here, but of course, if we've got something like solid rock that requires drilling and blasting, well, it's going to be more expensive. So that's the cost that the vertical optimizer considers. We're going to just set that vertical optimizer up. So we're going to say, well, we want that minimum maximum grade of 8%. We can put in our minimum K values for sags and crests. We can add in a control point if there's anywhere that we'd like to be at a certain location or within a tolerance of a certain location. And I think I'm good with that. So I'm going to run this. I'll hit process. It's going to, again, be one of those times where the software is going to think for a bit as it samples and then solves for our cheapest vertical alignment for the horizontal alignment that we've supplied. And it's plugging away there, so shouldn't be much longer. Or the dialog that we're seeing now, it's sampling along our alignment to kind of get a feel for what the problem consists of, but the actual solve, first solve is done. It's going to do another momentarily. And we'll hit OK. And voila, we've got a proper vertical alignment going from, well, right from the existing road out to our last turbine location. We can see our mass haul is, well, tracking very close to that zero line. We can see our data table here. We've got our cuts and fills. We're very close to balancing. And then the costs that the optimizer is using to solve, it's also reporting that here. So we've got a total cost for our subgrade at 176,000. I should mention it's not, yeah, it's not 100. Yeah, so we've got one done. The next one's going to be very similar. Same cross section, so we can kind of skip over that. We'll run our polyline to alignment. So we've got that. Then we'll set up that vertical optimization. We'll add in a control point at the start, so those two roads kind of marry together nicely. And we'll hit process. And voila. So we very quickly just, well, figured out our roads to 4 turbine locations. Of course, I was talking that whole time, and we still managed to do it fairly quickly. Quick recap before I switch over and we run through kind of the more involved approach where we're going to account for our pads. Workflow-wise, we brought in our survey data. We took that turbine locations that we already had, connected the dots, and then we ran Path Explorer and brought it over to location and turned it into a proper design. So.
Perfect. And then as we move into the second workflow, this is going to be our more detailed sort of road network planning. So in this one, we're going to take it a few steps further. So very similar to the first one, we're going to build a surface, we're going to import some turbine locations, but now we're going to include and account for the pad geometry and the crane laydown areas. So we're going to bring those into our terrain module, and then we're going to quickly explore and those road location options between the turbines. From here, we'll move ahead, take that back into location, get that detailed geometric road design, but now inside of our location optimization, we're also going to include those pads as reference features. And so that way their earthworks are actually going to be accounted for within the overall optimization. Finally, in this one, we can get quantities, some cost estimates, add culverts, because that's taking it a step further because this is a little bit more detailed, and talk a little bit about how you can output the design. So with that, I am going to pass it back to Matt. And yeah, we'll go through our second workflow.
All right, with the pad workflow, we're going back in time to where the two workflows diverge. So with that, we're not going right to square one. We've already brought in our LiDAR data, we've modeled our tin, we've created our streams and ponds, and have brought in our turbines. But we're going to set our pad orientation before we go anywhere else. So with that, we're going to click Insert File. We're going to bring in some predefined pad geometries. So typical pad geometry is going to be our starting point. We can use this in a variety of different formats. I've got them in a terrain format here to start. So I'm going to just bring those in. We'll click Open. We'll click OK. So nothing appears here. I'm going to click Zoom to Extents, and we can see those pads way down here at the bottom. And we're going to move those up to be in line with our project, just so it's a little easier to keep track of things. So here I'm going to click Move by Rectangle. We'll grab this. We'll pull it up there. We'll hit Zoom to Extents. We'll move this over once more. And away we go. And with this, I'm going to start out with this guy here. I'm going to use these as templates. So I'm going to copy it. I'll hit paste. Then I'm going to move it over to where I'd like to use it. So if I expect that's going to be the spot for this thing, well, great. And this one, I don't think I need to really rotate it much, but let's shift it down. And here I'm just shifting it down. I'm going to get into the nitty-gritty in location, but yeah, just making sure it's at a reasonable orientation. So I'm content with that. I'm going to move by vectors. So I've got that one where I'd like it to be. Well, let's go with this guy here next. Same thing. I'm going to copy it, paste. Now I'm just hitting Control M to move that, but I could very easily use the ribbon at the top. I'm gonna situate this around where I'd like it. Now it's hard to see where that lands, just floating there in space. So we are gonna, again, shift it down to be closer to a reasonable elevation. Let's rotate it a bit more. And we'll click this. So we've got that one. We'll, once again, copy, paste, move that to where we think we'd like it. Again, just to make it a little easier to see what we have going on there, we'll shift that down to be close to the desired elevation. I think that's actually probably reasonable. We can capture the gist of that when we include it as part of our road, figure out the elevation from the road. And then last but not least, so again, hard to visualize when it's floating up in the air like that. So we'll shift it down. And just to try and get a little bit of a visual on whether we're, oh yeah, that's good. I want that to poke out. And we'll just line up that turbine location and we're good. So I'll hit save here. And this, well, I suspect might have seemed kind of like a odd thing to do where we're not actually finishing the design for these pads that we've positioned in terrain. But what we're going to do here is these pads have features associated with them. So I'm going to set the laydown extents based off of a reference feature in location. I'm going to set the crane pad extents based off of a reference feature in location. And yeah, same for our storage extents. So that's saved. We're going to switch over to location here. We're going to click new file. So yeah, running through the same motions here now. So topo with pad, it's one that we were just using. Oh, silly me, I'm getting ahead of myself. Of course, we need the roots. So yeah, we're going to run the Path Explorer tool here. And instead of going right to the turbine location, we're going to say, well, we want to go from our start point to the start of the pad. And here it's set up just the same as last time. So my polylines are in there as that. We're going to set that. And let's just run this here again. So we want to go from here to there. That, and that. So, and I won't do 5 to start, we'll just do the 1. Unlikely to improve. Great. We'll go over here, same thing. So started in that direction. We want it to tie in from that direction. We'll go over to here next. And yeah, as Aaron said, it might seem like it takes a long time just watching this thing, but really we're designing, well, what are we at? Probably a kilometer in a few seconds here. And there we are. And from there to there. And this one will be the one that takes a little longer. So with that, yeah, it's one of those things. The more complex the problem, generally the longer it will take. And this, there's a lot of possible solutions where it's not necessarily clear which one's the best one to get from there to there. So it's, yeah, takes a little bit longer than these somewhat smaller problems.
Matt, if you're up for it, we've got a couple questions in the chat here to tackle. We got some solve time. Actually, this first one seems quite relevant because I think you're going to do it here in a few minutes, which is how did you join the paths before?
Oh, okay. Yeah, so we join them by using the join function. So we'll just select both features. And I probably hit Control J on my keyboard rather than clicking it in the ribbon or a right click. But yeah, it's just select the features you'd like to join and click join. So I will emphasize that when I do it here in a moment. And this is saying unlikely to improve, so we'll hit cancel. And there we are. So to answer that question with a actual demonstration. So I've got my 3 features selected. I would normally just hit Control J, but we can right click, modify selected features, join, or we could go up to feature tools and join. And similarly, when I break, basically the same idea. I could hit Control Q, I could right click, modify, break, or I can come up here and we'll break at our current point. And now I'll hit save and we'll switch over to location. And the next part of this workflow that makes it a little special, we'll set that up with our template. So here, new file, we'll reference that topo with pads. We'll select both of those XPath features. And once again, we'll do the big one first. So I won't worry about my background, but I will set this up so we can see it. So let's set our current point right here. We're going to go over to our templates. So in the last example, we just used this default low volume road. In this example, we are going to use this template that I already have, well, set up in the sense it's a collection of components. But here we've got the road component that's the same. We've got the ditch components that's the same, and the slope components that's the same. The thing that makes this one different is I've got, well, a few different components in between those that represent my pad. And here I have them named different things, but those 6 components here come from the E library. So the E library gives us a collection of a bunch of different cross-section components that we can use, lift and adapt without having to reinvent the wheel. And so this one here is what I'm using. And when I use it up here, this crane pad, I'm going to go in here, and instead of having an offset width of 0, I'm going to set this to be relative to one of those terrain features that represent the edge of my pad. So we're going to go in here, we're going to click Add. We're going to say, well, we want to create a reference feature that comes from our topo surface terrain file. We're going to give it the name, and so we want to run with our crane pads here. So we're going to select these. We'll hit select. We'll hit OK. And then we'll click the little drop down, and we've got that. And we'll do the same for our storage pads. We're going to make this another reference feature. So our storage pads are going to be this guy here. And we can see, well, something happened here. It's going off to the side, which is good. That's what we want. And then we're going to do the same with our laydown area. So reference feature 1, I've got it set to be our crane pad extents. Reference feature 2, I have it set to be our storage extents. And reference feature 3, we're going to set that to be our laydown extents. And we'll select that here. And there we are. So we can see that that's going out to that edge and that's going out to that edge now. So we'll hit OK. And nothing happens here. And the reason nothing happens here is because we don't have that template assigned. So in assign by range, that template, we have our default set. Well, let's go with that one that we've just set up, which is our WF wind farm template. And we'll assign it for our whole road from the start. So station dot dot to the end, station dot dot. We'll click Add Edit. We'll hit OK. And there we are. We can see that is being applied. So we've got the template that we'd like to use assigned. Next, everything, well, becomes very familiar again. So we're going to run that polyline to alignment. And we'll let this sink for a bit. And well, we're close to that tolerance. I could let it keep going. We're going to hit cancel and we're going to just run with that. So we've got those curves set. And here we'll apply a quick ground type. So most of this I'm going to just leave as overburden, but I'm going to say, let's go out here. So this little pinnacle that we're dealing with, we're going to say that that's shallow bedrock from station 1830 to station 1930. So we can assign that subsurface information if we'd like. And of course, we could do this in all sorts of levels of detail if we'd like, but I'm going to just do it for this one particular spot where we'll say we've got hard pan over, let's just put it over a single layer. We'll say it's 1 meter deep. And we'll assign that, well, 1830 to 1930. So here, instead of just assuming it's all the same, we're going to have some different costs. We're going to set up our vertical. And here, when we do our vertical optimization, I'm going to treat my pads a little differently. So from station 370 to station 550, I want to make sure this portion is not in a crest or on a steep grade. So we're going to set that to be on a vertical tangent. Same with out here. So we'll go 15, I'll use 1510 just to keep the numbers nice and round, to 1680. Oh, and out here, we'll extend this out a little further. So this is another thing too. You're not stuck with whatever you get. And here I can move that around and work with it. So we'll go from 3020 onward. So back into our vertical optimization, we're going to tell it to sample just like we did before. We're going to set our minimum and maximum grades for most of our design. And we'll click Add Edit. And then we're going to chunk that up. And for where we have those pads assigned, I want to grade no steeper than 2%. And I don't want any curves in there, so I'm going to add a linear constraint on those stations that I mentioned. We're going to apply those. So 370 to 550, 1510 to 1680, and then 320 to the end. And instead of typing in the station at the end, I'm just going to put ... That's going to capture it for me. So one less number to remember. We'll hit process. We'll hit OK. We'll hit OK. And it's going to run through, do that sampling. Once the sampling's done, it's going to, well, figure out where our curves tangent should be, what grades we should be dealing with, and what elevation everything should be at. And it's going to consider the problem as a whole, minimizing our costs, and adhering to those design constraints that we've given it. And there we are. So we can see at the end here, we're on a 0% grade. If we click in at this location where we added that second layer, we can see we've got some different cut slopes being applied based off the material that we're dealing with. Through here, again, we're maxing out that 2% grade that we've applied. And way back here, we've got that, well, 0.4% grade happen to be the best one. And we've also got a crossfall being applied to that as well that we have assigned in the template. We can see our cuts and fills. Obviously, we've got pads now, so that number is bigger. And we can see our total cost also bigger. We're moving more dirt. If we'd like to add something like a pipe, we can add in a pipe, and I won't add all of them, but we certainly can add our culverts in. We can size that however we like. So if we decide, well, I'd rather put in a 400, we totally can do that. We can remove a ditch override too if we want to do that. So lots of flexibility there. And then when we're happy with what we have, we can go over, if we want to produce documentation for construction or permitting or consultation, we can throw that together really quickly in the multi-plot editor. So here, and I won't go into a ton of detail on this, but we'll set that up to, I'll have our plan over profile. So we can see that. We'll add in a second one for a second chapter for our cross sections. Away we go. And then if we want to take that out in a digital format, we can hit File, Save As, and we can run with, well, a bunch of different export options for what we might want to export that to. So DWG, DXF, DGN, land XML is a really nice one. Just coordinates file if we want to stake to point for construction. All sorts of different options there. And with that, I did go over. I thought I'd do better than this morning, but nope, I'm right around the same. But we can answer a few questions.
Yeah, there's a couple here in the chat. Okay, first question was, can you account for a control point in Path Explorer?
Yep, totally can. And so with that, and I'll just, do I have the other one open? No, I don't. But basically it's the same as what we did when we ran the Path Explorer to the actual turbine locations rather than the pad locations. It's just that control point's a point. So we run A to B, B being that control point, and then we run Path Explorer again from B to C, again, that B point being that control point, and then we join them afterwards. So yeah, it's could be something like this where we're stringing them along for a target, or it could be something like a bridge location where you want to be right where that abutment's planned. But absolutely can account for control points.
Okay, another quick one, well, maybe quick one, which is, can you compare the costs between different Path Explorer options in location?
Yeah, so yeah, so in location, I'll just try and cover my bases here. So in terrain, and just to reiterate, the number that comes after the XPath is the expected cost based off of what we have accounted for when we set it up. Location is going to consider the problem in a whole lot more detail. So with this, we can see our costs down here. And I don't have another XPath alignment to just apply and attach this to. But we could do a quick comparison if we had one. And in this case where I don't, I can just say, well, what happens if we want to make an adjustment and compare the adjusted alignment. So if I come over here and I say, well, what happens if we move this over there? Well, everything is updating. So I've pulled this over here and we can see, well, everything is interconnected. So even if I don't vertically optimize this, I can still use that costing functionality to compare options. So I can click a quick recost. And there we go. So that other one is 2,000 bucks, 2,500 bucks cheaper. But we can do that side-by-side comparison with different options anywhere along the way if you'd like, and you can have the costs be reported side-by-side to each other.
And this question actually reminds me of a question we had in our morning session for this webinar, which was asking about comparing different road widths. So in this case, they were asking the question if we could, adjust our road width to be wider so that we didn't have to deassemble the cranes versus keeping it more narrow, and what would be the cost implications of that. And that's something that I believe you can do exactly through the same workflow that Matt's showing right now.
Yep. So I'll just, it was a good question. I'm gonna duplicate this. So instead of just arbitrarily moving something over, we can even compare something where the alignments are the same. We just have those different cross sections attached. So for this H-align 3, I'm gonna say, well, what happens if we run with that wider road prism from this pad to that pad? How much is it gonna cost us? So we'll go up here. We can see I have another template that's called, well, wind farm wide. So instead of running with and let's see what we have here. Instead of running with a 5-meter wide prism, so 2.5 either side, we're going to run with a 10-meter wide prism, 5 either side. And here this looks funny just because I've got some curve widening being applied, but they are the same if we're somewhere without curve widening. So for that, we're going to hit assign by range. We're going to go to templates, and we're going to assign that other template from station 1700 onward. We'll hit this guy here. We'll hit OK. We'll even do a recast cost right off the bat. And, well, just leaving that in the same location, we've gone up quite a bit. So doubling our width here is pretty costly. Now, of course, we've changed the width, so we probably would be best to also redo our vertical optimization. And when we redo that vertical optimization to reflect our new conditions, we'll see we drop that down substantially. But hopefully that, well, I guess it wasn't asked in this group, but hopefully that makes sense for those of you that are following along. Yeah. And it'll just be a moment and we'll get that new updated vertical alignment for our new horizontal that has that wider road at the end of it. And there we are. So we've gone from 320 to still 430-ish. So yeah, still expensive, but that makes sense. It's a bigger road.
And with that, we are 15 minutes over in classic Softree webinar fashion. So there are, like I see, 2 more questions here in the chat. We'll tackle those with the question askers individually. And I just want to thank everyone for coming today. Check out the full calendar up at softree.com/webinars. And we look forward to seeing you all at another session sometime soon. Thanks, everybody.
Yeah, thanks, everyone.